Isaac Newton exists in our collective memory as the solitary architect of modern science. We envision him at a desk like this, crafting the laws of gravity and motion through sheer, unassisted willpower. Popular legends suggest his discoveries arrived in sudden, effortless flashes of clarity. But the historical record tells a different story, one of a man working for years in near-total isolation, obsessively refining a single idea through thousands of iterations. Newton was trapped by analog friction. In the 1600s, proving a mathematical theory required months of manual calculation. Every variable had to be checked by hand, using nothing but ink, parchment, and a candle that was constantly burning down. Beyond the math, his physical environment was a wall. He lacked precision instruments to measure the stars, and had to wait months for letters to travel across Europe just to hear what other researchers were seeing. Newton's mind operated at a speed his tools couldn't match. He was a scientist capable of modern insights, but his era forced his actual output to a crawl. Today, that physical wall has collapsed. We operate in a digital landscape where data moves instantly and computation is effectively free. We have built artificial intelligence to serve as the ultimate friction destroyer. It is a system designed to solve the exact problem Newton faced, the agonizing delay of processing information. AI offers the instant synthesis and global communication that Newton lacked. It can verify in seconds what used to take him a lifetime of manual labor. This raises a fascinating possibility. If we could bridge the centuries and arm history's most potent mind with this frictionless tool, how would the timeline of human progress change? Combining Newton's raw intellect with the processing power of AI creates a unique test for the limits of scientific discovery. In this hypothetical 17th century, the first change is the total removal of manual labor. The agonizingly slow scratch of the traditional quill is permanently replaced by the lightning-fast, silent hum of automated digital execution. This timeline represents a complex mathematical proof. Under Newton's hand, it spans years. With AI, the process collapses into a single millisecond. That result then expands into a live simulation, modeling thousands of intersecting orbital trajectories simultaneously, instead of taking decades. A theory is tested, it is validated instantly, or discarded in real time. By offloading the arithmetic to the machine, Newton's entire cognitive capacity is freed. He is no longer a human calculator. He is a pure theorist. Automating the execution of science scales a single researcher's output to that of a modern university. But the real shift happens when the AI begins to look for things Newton couldn't see. AI is built to find patterns across massive global datasets. It can ingest centuries of astronomical observations from across the world, identifying subtle gravitational anomalies that would be invisible to a human eye staring at scattered charts. This entirely ends Newton's long intellectual isolation. The machine provides him with an omniscient view of every data point available to humanity, synthesized into a single stream of evidence. With the grind of basic physics finished in his 20s, Newton's theories would likely push toward the boundaries of his own laws much earlier. Consider this image of a black hole. In our timeline, it took 300 years to develop the math to predict this. But if an AI pointed Newton toward gravitational extremes his own equations couldn't explain, he might have begun grappling with the warping of space and time while he was still a young man. If the computational work of 3 centuries is condensed into a decade, the transition to the age of astrophysics begins in the 17th century rather than the 20th. Even with this massive acceleration, there is a hard boundary between what the tool does and what the scientist must do. AI is a master of processing what is already there. It can find every pattern in a dataset, but it possesses no imagination. It doesn't wonder. An AI operates within a rigid grid of logic. It can optimize forever, but it cannot create a ripple that changes the grid ship. It takes a human mind to provide the original intuition, the spark of curiosity that asks why the grid exists in the first place. Breakthroughs like relativity still require a human to ask an unprecedented question. The machine can solve the math, but it cannot conceive of the concept. Scientific progress requires this two-part anatomy, a machine to handle the known and a human mind to pierce the unknown. This isn't just a historical what-if. This is the reality of the AI revolution we are living through right now. The lesson of our Newton experiment is clear. AI is a limitless engine for processing, but it cannot substitute for visionary thought. Today, the value of routine computation and data gathering is approaching zero. Because the machine can do it instantly, the value of human creative inquiry has never been higher. In an AI-driven future, your most important skill isn't finding the answer. The machine will give you that. Your skill is knowing how to ask the question that no one else has considered. Technology doesn't make genius obsolete. Instead, it amplifies our imagination, allowing us to reshape the future just as Newton once reshaped the past.